All right, welcome back, and we are going to take a cumulative ACT practice over Unit 6 and 7, which was plane geometry and trigonometry. So you have 16 practice problems. Good luck to you. Try this one, hit pause, come back when you're ready. And hopefully you got 48 inches squared. Okay, it says triangle ABC is an isosceles triangle. So that means the base angles are equal and those sides are equal. Whose base angles are A and C. AC equals 12, which means each of these are 6, because in an isosceles triangle, if you connect the vertex to the base perpendicular, it becomes a bisector. Okay, and then let's see, what else does it tell me? It says BC equals 10. And it says if the height of the triangle, which is BD, is 4/5 of the length of AB, which is also 10 because it's isosceles. So BD is 4/5 of 10, which 5 goes into 10 twice. So the length of BD is 8. And the area of my triangle is base times height divided by 2. Well, my base is 12. My height is 8, which makes 96 divided by 2 is 48 inches squared. Okay? Hit pause, come back when you're ready. And hopefully you got 61. It says, given the triangle below, what is the measure of angle FGE? Well, the three angles of a triangle have to add up to 180. So if I take 180 minus 92 minus 27, that leaves me with 61 degrees. Okay? Try this one, hit pause, come back when you're ready. So they want to know which of the following choices is not a list of the lengths of the sides of a right triangle. Well, remember, for the right triangle, I didn't realize it was a right triangle, but any triangle, the two smaller sides have to add up to more than the longest side. So for A, is 12 plus 16 greater than 20? Well, yeah, because 28 is greater than 20, so that's true. 4, 5, 6, 4 plus 5 is not greater than 6, because 9 is not greater than 6. So that would not make any triangle, let alone a right triangle. And we could check the other ones. 5 plus 12 is greater than 13, because that's 17. 7 plus 24 is 29, which is greater than 25. And 8 plus 15 is greater than 17, because that's 23. So all the rest of them work except for B. Okay? All right, hit pause, come back when you're ready. And hopefully you got J. It says the radius of a sphere is 6 meters. What is the volume of a sphere? Well, volume of a sphere is 4/3 pi r cubed. So my volume is going to be 4/3 times pi times my radius, which is 6 cubed. 6 cubed is 216, so I have 4/3 times pi times 216. If I take 4/3 of 216, I get 288 pi, because they obviously left my answers in terms of pi, and volume is always units cubed. Okay, try this one, hit pause, come back when you're ready. And hopefully you got angle, side, angle. Okay, side, side, side postulate wouldn't work because I'd have to know that this side is congruent to that side and this side is congruent. I don't know that. I can't assume that. So that won't work. Angle, side, angle, well, just from the picture right now, no, because I have angle, side, nothing, or side, angle, nothing. Angle, angle, side isn't a postulate, I don't think. Anyway, those won't work. So why are they getting angle, side, angle? Well, there's a theorem that says if two angles of a triangle are congruent, then the third angles have to be, because they all have to add up to 180. Well, if two are the same, then the third one is whatever 180 minus them is, which is also true in the other one. So those are equal. So I know that all three angles are equivalent, but that's not even a postulate. That does not exist, because remember, you could have three angles that are equal, but the triangles could be similar instead of congruent. So that's not even a postulate. So again, I'm thinking, okay, I know that it can't be either of these guys because I don't know two of the sides, and I don't know two of the sides, so it can't be that. But my problem is, this doesn't really ring true to me because I don't know, well, now I do, angle, side, angle, because I can conclude that those two are equal. So therefore, we would use angle, side, angle. Okay? Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got H. Okay, we didn't do much of this when we were doing the transformations. I think there was like one problem where they put that in one of the choices, but they never really talked about it. So I will talk about it now. The line y equals x, that's the mother function of all lines. It's called the identity function. Okay? And it's right there. Well, when you reflect a function or a picture over the line y equal x, that's definition of inverse functions. Inverse functions will reflect each other across the identity line. So what that means is when you have inverse functions, what it means is you switch x and y. So if I want to reflect this, instead of p being 2, 1, we say p prime, meaning I'm transforming it, would be 1, 2. And if q is at 4, -3, then q prime, meaning what I get when I transform it, would be at -3, 4. And if I draw that, I get 1, 2, and -3, 4, and it would be right there. There would be p prime, and there would be q prime. And it's reflected over y equal x. Okay? Alright, try this one. Hit pause. Come back when you're ready. Alright, and hopefully you got A. In the figure below, L and M are parallel, and both lines are cut by the transversal T. Which of the following is a complete list of all the angles congruent to angle 8? Well, the first thing I noticed is that angle 8 is congruent to angle 5 because those are vertical angles. Okay, and then I know that angle 8 is congruent to angle 4 because those are corresponding angles. And then because angle 8 equals angle 4 and angle 1 equals angle 4 because they're vertical angles, or you could also say that angle 8 is congruent to angle 1 because they are alternate exterior angles. Okay, so there's the list of all the congruent angles to angle 8. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got K. Alright, here's what cracks me up about ACT. We went through all of these units and we talked about similar triangles and all that other stuff, and nowhere in any of it did we talk about area. Until now. So, of course, we'll talk about it now, I guess. Alright, so there's a theorem, I guess, that says when two triangles are similar, the areas are proportional by the square of the factor. Well, since I can say that they said that they're similar, so DE corresponds to AB, so I can say that DE is 1/3 of AB, because 9 divided 3 over 9 would be 1/3, so that's DE is 1/3 of AB. Well, it says by the square of that factor. Well, if I square 1/3, that's 1/9. So the area of triangle DEF has to be 1/9 of the area of triangle ABC. Well, I know that the area of ABC is 36. So the area of DEF is 1/9 of 36, which would be 4. Okay. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got 4 inches squared. So it says in the rectangle ACDF, the big one, AC is 3 times as long as BC, which means this whole thing would be 3 inches. Well, if I were to use 1 inch here, then from here has to be 2 inches. The width is 2 inches, so this is a square. The area of a square is base times height, which would be 4 inches squared. Okay? Alright, try this one. Hit pause. Come back when you're ready. Yeah, and hopefully you got 15 inches. So it says if the circumference of the circle below is 30 inches and angle ABC is a right angle, what is the length of arc AC? Well, we know if you have an inscribed angle, the arc is twice the angle. So arc AC would be 180 degrees. Well, how are they getting 15 inches out of 180 degrees? Well, 180 degrees is exactly half of the circumference. So what I want is half of 30, which is 15 inches. Okay, cool beans. Try this one, hit pause, come back when you're ready. And hopefully you got 3. So it says a sphere with a radius of 3 has the same volume as a right circular cylinder with a height of 4. What is the radius of the cylinder? So I need 2 formulas. I need my volume of sphere, which is 4/3 pi r cubed, and the volume of a cylinder, which is pi r squared h. Okay? And it tells me that these volumes are the same. So if these are the same, then this has to equal this. So I can say 4/3 pi r cubed of the sphere has to equal pi r squared h of the cylinder. And I'm going to plug in what I know. And I know that the sphere has a radius of 3. So 4/3 pi times 3 cubed. And that has the same volume as a right cylinder with a height of 4. So here I replace the radius, and here I'm going to replace the height with 4. So on this side I have 4/3 pi times 27, and over here, I have 4 pi r squared. I'm trying to figure out what r is, so if I do this multiplication, take 4/3 of 27, I get 36 pi equals 4 pi r squared. Again, I'm trying to get radius, so I'm going to divide by 4 pi, and I get radius squared equals 9, square root, and I get my radius has to be 3. Alright, hit pause, come back when you're ready. Okay, and I do not like these. I don't like the transformations because they give you this itty-bitty graph, and by the time you draw all over it, you can't keep track of what you checked and what you didn't check. But with this, I can erase every time I try. Alright, so they want to know which of the followings could not be used to place the triangle ABC on top of triangle DEF. Alright, if I reflected over the y-axis, okay, that would put me like this. Okay, then if I slid 6 units up, 1, 2, 3, 4, 5, 6 up, 1, 2, 3, 4, 5, 6, that puts me way up here, 6 units up. And then if I flipped over the line y equals 3, there's my line y equals 3. Well, this is 1, 2, 3, 4 units above, so 1, 2, 3, 4 units down would flip down, flip down, so that would put it right on top of DEF. So F works. And like I said, but on the ACT, you've got one graph, and now you've already drawn all over it, so unless you want to try and draw it all over again, which kind of stinks. Alright, let's try the other one. So G, if I rotated 270 about the origin, well, this would be my point that I reflect around. So over here, and I don't draw rotations, so this is going to fall down 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. It's going to look like this when it flips 90 degrees, okay? Then 180 degrees, it would flip down, so it would just look like this, okay? And then 270 would put it over here, and without trying to draw it perfectly, okay, that's obviously not on top of DEF, so that's the one that would not place it on top of the other one, okay? And then again, once you found it, of course, in a real ACT, I wouldn't waste time checking the others, but just for practice, for H, it says reflect over Y and then reflect over X. Well, if I reflect over Y, I get this. And then if I reflect over X, I get this, which puts it right on top. So yes, that works. And then we just did the 180, rotated 180. We did 90, and then we did 180, which did put me on top there. It was that other 90 that got me off. Okay, so that would work. And then if you go negative 540, that's the same thing as going positive 180, so that works also. Okay. All right, try this one. Hit pause. Come back when you're ready. And hopefully you got pi over 2. Alright, you can do this a couple different ways. What they want you to remember is the graph of cosine function, which oscillates between 1 and negative 1. Period is 2 pi. Cut that in fourths. So this would be pi over, this would be pi, so this would be pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And cosine starts at the amplitude, goes to 0, down to amplitude, back to 0, up to amplitude. There's cosine. Well, which of the following values of theta will make the function equal to 0? Pi over 2 and 3 pi over 2. Well, the only one that's there is pi over 2. The other thing you could do is just type them in the calculator. Now, you got to make sure, because these are in pi's, you got to go to mode. And about the fourth line down, you choose between radians and degrees. You need to make sure you're in radians when you're typing pi's. So switch your mode to radians, and then if you type cosine 0, you get 1. If you type cosine pi divided by 4, you get 0.707106, blah, blah, blah. If you type cosine pi over 2, you get 0. If you type cosine of pi, you get negative 1, and if you type cosine of 2 pi, you get 1. Which you could also tell from the graph. Again, if you knew your graph, pi over 4 would be somewhere right here, so it's 0.7. Pi over 2 is your 0. Pi, see, you're down here at negative 1, and 2 pi, you're up here at positive 1. Okay, so the one that gives me 0 is pi over 2. Okay, try this one. Hit pause. Come back when you're ready. Come on. There you go. And hopefully you got negative 3/5. If tangent of theta equals 3/4 and theta lies within the third quadrant, so I'm down here in quadrant 3, which means my reference angle is down here. There's my theta. And it says that tan theta, which is opposite over adjacent, is 3/4. Well, opposite would be here, adjacent would be here, but in the third quadrant, that's negative and that's negative because we're going left and we're going down. Okay, and the reason they got positive 3/4 was because a negative divided by a negative is a positive. Sine now is opposite over hypotenuse. Well, we know that if this is a right triangle, the most famous right triangle there is a 3, 4, 5. I mean, you could do Pythagorean theorem if you wanted to, but just remember that 3, 4, 5 is the most famous right triangle of all, just like Rudolph. Sorry. Okay, so for my sine, opposite would be -3, and my hypotenuse is 5. Okay, hypotenuse is never negative. It's a leap. Okay, so my sine would be -3/5. The trick is to make sure you put your reference angle in the right quadrant so you get the sines of your legs. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got tan squared. Okay, 1 minus cosine squared. Remember our most famous Pythagorean theorem, sine squared theta plus cosine squared theta equals 1. So if I subtract cosine squared theta, I get 1 minus cosine squared theta equals sine squared theta. So I can rewrite the top as sine squared theta. On bottom, sine squared theta is here times cotangent squared theta. Well, that cancels, so that leaves me 1 over cotangent squared theta. Well, by reciprocal property, that is tan squared theta. And there you go. Okay. Alright, try this one. Hit pause. Come back when you're ready. Okay, and you have a couple choices here again. You could do this with a calculator. Say sine 30 degrees equals x over 15. If I'm trying to get x alone, I would multiply by 15. That cancels. Now, again, check your mode. Because these are degrees, you got to switch it back to degree mode. And when you type 15 times sine 30, it will give you 7.5. Or you could remember, if theta is 30 degrees, then we're in a 30, 60, 90 triangle where my short leg and my long leg is x square roots of 3 and my hypotenuse is double the short leg. Well, it tells me that sine of 30 is opposite, which is x, over hypotenuse, which is 15. Well, if 2x equals 15, to figure out what x is, divide by 2, and I get x equals 7.5. Okay, so one of those methods. Alright, and that will do it for this little practice session we had. And I will see you next time.